There have always been advantages to working with Acme Steel Company. Being an integrated steelmaker gives Acme a quality advantage and provides our customers with top-quality steel products. Acme's position as North America's most flexible integrated steelmaker also works to the company's advantage, helping it carve out market niches among customers looking for specific or specialized steels in small order quantities. In the autumn of 1996, Acme completed its new compact strip production facility in Riverdale, Illinois, which made the introduction of integrated steel a reality and redefined the steelmaking process. For the first time anywhere in the world, Acme Steel combined the high-quality benefits of integrated steelmaking techniques with the efficiencies of state-of-the-art thin slab casting and rolling technology. The result is integrated steel, the most important advance in steelmaking in over a quarter century. And the advantages belong to Acme's customers and shareholders. The production of integrated steel still begins at Acme's coke plant in Chicago, a world-class facility that produces high-quality, consistent coke. Coke is made by blending, then heating as many as 6 different types of coal in one of Acme's 100 coke ovens. A solid program of operational maintenance and state-of-the-art environmental controls ensure that these ovens will continue to meet Acme's coke needs. The finished coke travels by conveyor to Acme's blast furnace plant, where it's combined with iron ore pellets and other raw materials, and smelted into liquid iron. Smelting occurs when a blast of air heated to 1875 degrees is blown through the burden and burns the coke, converting the iron ore pellets into molten iron. The iron travels by special rail car to Acme's basic oxygen furnace, where it's processed along with carefully selected steel scrap. Here in 2 100-ton furnaces, oxygen is blown into the vessel at supersonic speeds, refining the iron and scrap into high-quality liquid steel. The use of integrated steelmaking technology is the basis for Acme's product quality advantage. In the new world of integrated steel, this advantage has expanded. The ladles are placed on special transfer cars and transported to Acme's compact strip production facility. The CSP is among the most modern steel manufacturing plants in the world and the heart of Acme's integrated steel advantage. Integrated steel combines integrated steelmaking quality with mini-mill efficiencies. The CSP expands an exclusive Acme advantage, allowing it to efficiently produce the special grades and small order sizes typical of the company's niche market customers, while improving the overall quality of its steel products. When ladles of high-quality liquid steel arrive at the CSP, they immediately enter one of 2 ladle metallurgy stations. The steel then begins its final step toward becoming hot-rolled coils of integrated steel. What once took 10 days will now happen in 90 minutes. Ladle metallurgy permits precise, computer-formulated refinements to the steel's chemistry to meet exact customer specifications. Alloy additions are computer-controlled, and argon bottom bubbling ensures uniform alloy distribution. Each metallurgy station is also a furnace. Carbon electrodes heat the steel to the targeted casting temperature, then maintain it until the steel's precise chemistry has been attained. This is verified by testing samples of the steel in the Quality Control Lab, located within the LMF facility. When it's time to cast, ladles are transferred to the turret atop the continuous caster. The turret holds 2 ladles to ensure continuous operations. When a ladle is empty, the next swings into place to continue the cast. The empty ladle is returned to the basic oxygen furnace to receive its next heat. Steel flows from the ladle into the tun dish, a reservoir that holds the steel and distributes it evenly for casting. A ceramic shroud helps ensure clean steel by shielding it from contact with air, which would result in contaminating oxides. Steel cleanliness is further enhanced by the tun dish's internal design, which allows non-metallic inclusions to float out of the steel before it's cast. Automation plays a leading role in the production of integrated steel. Closed-loop process control computer systems augment each of the CSP's major functional areas and optimize the setup of individual machines, ensuring that exact customer specifications are automatically achieved. That data is relayed to a production planning and scheduling computer system, which oversees the facility's operation by creating an optimal production schedule. It combines an analysis of current sales and factory orders with data from the closed-loop computer systems. The computer then configures the schedule that is most advantageous to the customer and Acme. As casting begins, the steel flows from the tun dish into a copper water-cooled mold. A specially designed nozzle prevents oxidation and optimizes steel flow into the mold. While a skin begins to form on the steel's outside surface, the water-cooled mold oscillates up and down to strip itself from the solidifying shell. Mold powder, which covers the steel's surface, is added to further prevent oxidation, and after melting, lubricates the steel as it travels down through the mold. Two enhancements to Acme's caster provide improved product surface quality. An electromagnetic brake acts as a damper to quiet the steel's wave action at the top of the mold, and a hydraulic mold oscillator controls the amplitude and frequency of the oscillation movement. This represents an improvement over traditional mechanical oscillators and enables Acme to cast alloy and mid and high carbon grades of steel. The caster's adjustable width feature gives Acme the flexibility to produce a wider product range during a cast. With its state-of-the-art production control systems, Acme is also able to quickly react to customer changes by reapplying its product in real time automatically. As the steel moves through the caster's containment zone, a gradually thickening skin forms on the slab's exterior. A major quality evaluation is automatically performed on a number of casting variables, ensuring that the steel will meet the customer's exact physical and mechanical specifications. Two additional enhancements provide increased product quality. A spray mist system allows more uniform, efficient cooling, improving surface quality. Soft reduction improves internal quality by preventing centerline segregation. As the approximately 2-inch thick slab emerges, it's automatically sheared to the length required for a customer's maximum coil outside diameter. It then immediately enters the tunnel furnace. The fully automated 676-foot roller-type furnace controls slab heating, producing uniform temperature across the slab's width, length, and thickness. Computer control allows for virtually perfect heat control, as it automatically sets the furnace's temperature in line with the slab's targeted casting and entry temperature. Uniformly heated slabs mean less variation in hot mill finishing, providing improved mechanical properties and gauge control. It also allows scale to form correctly on the slab surface and come off more easily before hot rolling, enhancing surface characteristics. High-pressure water sprays clean and descale the surface as the slab enters Acme's 7-stand, 61.5-inch wide hot rolling mill, the world's most powerful mill in terms of horsepower per inch of width. The integrated process gives Acme's customers unprecedented flexibility with their steel requirements. It can roll a product twice as wide, as well as in much lighter gauges than Acme's former hot strip mill. Each of Acme's 7 mill stands is more powerful than the entire 6-stand mill at the old operation. The mill's computer-controlled features include automatic gauge control, work roll shifting, roll bending, and profile and flatness systems. The work rolls in these 4 high stands have a continuously variable crown, or CVC design. Based on a number of variables, the computer calculates the amount of roll shifting required to produce the desired strip profile. Shape control is further enhanced by the mill's roll bending capability. Computer-controlled hydraulic systems apply the appropriate force to bend the work rolls in a controlled fashion. As the strip passes through each stand, measurement data on force, speed, roll gap, and roll bending is continuously monitored. This information is compared to the predicted values and is sent to the next stand, so subtle changes can be made to the setup. The measurement data also is collected by closed-loop computer systems and continuously fed back to the mill stands to control rolling parameters, producing world-class dimensional control. The data gathered by this adaptive closed-loop system is used to continuously improve the mill's performance. In essence, the mill learns and teaches itself through experience by constantly updating mill settings for each product. As the hot rolled strip begins to exit the mill, it undergoes a series of automatic measurements, including X-ray, profile scanning, width, shape, and temperature. This confirms that a world-class quality product matching the customer's exact specifications is being produced. Roll changes on Acme's hot strip mill are well designed. Once the new rolls are put into position next to the mill stands, the old rolls are withdrawn. An entire floor section then shifts as the new rolls are lined up. They are then reinserted and locked into the mill stands. A multiple stand roll change can take place in as little as 7 minutes. After hot rolling, the steel strip passes through a laminar flow cooling system. Top and bottom computer-controlled cooling sprays lock in the desired mechanical properties, as specified by the customer. Controlled cooling provides uniformity across and throughout a coil, and from one coil to another. The mini-graded steel strip is then coiled. Acme's hot strip mill can produce world-class quality coils ranging from 35.4 to 61.5 inches in width, and from 0.040 to 0.500 of an inch in thickness. The expanded capabilities in coil width and gauge have strengthened Acme's market position. Larger, wider coils mean longer production runs for Acme's expanded range of customers. In addition, a key benefit of mini-graded steel is in its low residuals and nitrogen content. This gives our customers a more consistent product than other cast steels for their forming, stamping, and heat treating operations. As the coils come off the line, they're weighed, automatically banded, and marked with product identification. Coils are removed from the line by overhead crane or mobile equipment and are ready for commercial shipment or further processing. Equipment and technological aspects of the new CSP complex require a new breed of steel worker to operate the facility, which is managed with a modern, self-directed work team concept. The highly skilled and extensively trained people responsible for operating and maintaining the new equipment come largely from Acme's old operations. The company's long history of progressive training and education helped ease the transition and establish a self-directed work culture where lines delineating responsibilities and barriers preventing on-the-spot decision-making have been eliminated. Acme's full-service approach gives customers access to additional processing services for their hot-rolled coils. Acme Steel Processing, the company's joint venture with National Material LP, can pickle and slit up to 400,000 tons of integrated steel annually. Further downstream processing operations, including annealing, cut to length, and cold reduction, allow customers to streamline their purchasing efforts and reduce the logistical demands of moving steel to different processors. Yes, there have always been advantages to working with Acme Steel Company. By adapting state-of-the-art technology to its integrated steelmaking operations, Acme expanded a competitive edge that begins and ends with a quality product. Customers benefit from the company's increased capabilities, improved quality, broadened product range, greater flexibility, and improved response times. Acme has expanded its advantages with integrated steel.